Hello everyone, hope all is well today. The topic of discussion for today is simply the computation of a sample mean and sample standard deviation with a small sample. So here we have data from the United States. The statistical units are simply years, where we're going to describe that year with a number of deaths caused by tornadoes. For example, in 1990, there were 53 deaths due to tornadoes in the United States. Okay, and so here what we'll do is we'll compute the sample mean and sample standard deviation for this variable. And so the first thing that we'll do is we'll compute two sums, and so we'll add up the values for this random variable. So here we have 53 plus 39 plus 33 and so on right up to the last value, which is 90, and the total here is going to be 630. Okay, and then we'll also need the sum of squares to eventually compute the sample variance or the sample standard deviation. And so I'll compute 53 squared plus 39 squared and so on right up to 90 squared, and the sum of the squares is 50,030. Okay, so with these two sums we can compute some descriptive statistics. For example, I can compute the sample mean. So my sample mean, which I'll denote as x bar, this will be the total of the total of these values, which is 630, divided by the number of observations that I have. So I have 630, and then here, how many observations do we have? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 values, and so I end up with a mean of 63. So on average, there are about 63 deaths caused by tornadoes in the United States per year. Okay, so this is a description of central tendency. And then, since not all values are constant at the center, we'll try to describe how dispersed these values are by computing a sample standard deviation. Okay, so first thing we'll do is we'll use a shortcut formula, and so what we'll do is we'll compute the sample standard deviation as the square root of the sample variance. And how do I compute the sample variance? Where there's a couple of different ways. One shortcut formula is the following. It's the sum of the squares minus, and then I'll need to square total, and then that square I'll divide by n, and then all of this, the difference, I divide by n minus 1. Okay, so in our case, inside of the square root, what do we have? So in the numerator we have the sum of the squares, which is 50,030. I take away from that a square of the total, which is 630. That 630 squared I'll divide by 10, and then the difference I divide it by 10 minus 1, which is divided by 9 in this case. Okay, and then when I take the square root, I'll end up with the sample standard deviation. In this case, it's about 33.896, let's say. So 33.896. So a typical deviation away from the mean is about 33 or almost 34 deaths per year. Okay, so this is sample standard deviation, but with our shortcut formula. Alternatively, what we could do is go back to the definition of a sample variance and the sample standard deviation and compute it from the definition. It's a bit more tedious, but it is a reasonable way to compute it as well. And so what I'll do is I'll erase my work. Okay, and then what we'll do is simply keep our mean, which was 63, and then I'll show you an alternative way to compute the sample standard deviation, simply by using the definition. Okay, and so we'll recall that our mean was 63. So what we'll do is we'll create a little table where we'll have all of the observations. So here we have 53, 39, 33. Of course, in the video I won't put all the values, but you would have to put all the values right up to 90. And then what we'll need is compute difference between the observation and the sample mean. So I do 53 minus 63. I get minus 10. And then I get 39 minus 63, which is minus 24. Essentially, I want to know how far do each of the observations deviate away from the mean. And so it's 33. I take away from 63, I get minus 30. And I do this for all 10 observations. For example, the last value, which is 90, minus 63 is 27. Okay, and then I get the squared deviations away from the mean. So I'll square these differences. So minus 10 squared is 100, minus 24 squared is 576, and so on, right up to 27 squared, which is 729. And then what I'll do is I'll compute the total. So I add up these square deviations away from the mean. So 100 plus 576 plus 729, and so on. We end up with 10,340. Okay? And so now the sample variance, by definition, is the sum of the squared deviations away from the mean, where I divide that by n minus 1. So approximately, on average, how far am I away from the center? So here, I get 10,340. I divide this by 10 minus 1, and I end up with a sample variance of 1,148.889. Of course, this is in squared units, so this is number of deaths square, which is usually very difficult to interpret, and so we'll revert back to the original scale of measurement, which is number of deaths per year, by computing the sample standard deviation. So S, which is the square root of the sample variance. In this case, it's the square root of 1,148.889, and I end up with the sample standard deviation of 33.896, about, or 895. Okay, and so this is in deaths. So this is a measurement of dispersion. Typically, this is the number of deaths away from the mean. So it gives us some sense of how dispersed these values are. Okay, so this is your sample standard deviation. Alright, so that's it. This is how we compute the mean and the sample standard deviation by using either a shortcut formula or the definition. Alright, so thank you. Have a good day.